Hello and welcome to Unit 2, Part 3. Today we're going to talk about solving and justifying each step of multi-step equations. Solving multi-step equations is very much like a puzzle. I can't tell you a set way and a set number of steps to do for every particular equation because they're all different and they can get very, very complex. But I can give you some guidelines that steer you in the right direction. Generally speaking, when you're dealing with solving a multi-step equation, you want to simplify as much as you can first. Distributive property, combine like terms, move stuff from one side of the equation to the other if you can. Once you've kind of set that up, you want to undo your addition or subtraction components first, and then undo multiplication or division components last. That's just a general set of guidelines. The more you practice multi-step equations, the more you'll be able to address whichever one is in front of you. Let's take a look at the first one here. Says 3x minus 10 equals 20. Well, there's no simplifying that I can do. There's no distributive property. So let's begin with getting rid of the addition or subtraction parts first. If I want to undo this negative 10, I'm going to add 10 to both sides of my equation here. And I can do that because of the addition property of equality. So I'm left with 3x equals 30. And the reason that's true is the addition property we learned from a previous lesson. Your final step is to get rid of this times 3 in front of the x, in which case we will do the opposite and divide both sides by 3 to give me x is equal to 10, which is true because of the division property of equality. All right, let's take a look at the example on the right. There's no real simplifying that can be done. I'm going to undo the addition or subtraction operations first. So to cancel this negative 3 from the left, I'm going to add 3. And to keep my equation balanced, I'm going to add 3 to the right side, leaving me with 2/5 a equals 6. And that's true because of the addition property again of equality. And my final step can be done several different ways. Just the way I like to do it is to multiply by the reciprocal. You could divide both sides by 2/5. You could turn this into 2 more steps by multiplying both sides by 5 first, and then coming back and dividing by 2. I like to go ahead, multiply by the reciprocal of my fraction. That gives me 10 over 10, which cancels, leaving me with just a. However, if I multiply the left side by 5 over 2, I've got to multiply the right side by 5 over 2 as well. 6 times 5 over 2 gives me 30 over 2, which simplifies to be 15. And the reason a equals 15 is because, in this case, the multiplication property, because we multiplied both sides by that reciprocal of that fraction. Now, in this example on the left, we need to do a little simplifying first. And remember from a previous lesson, we can distribute here this negative 3 to both terms on the inside and get negative 3x. We could distribute this negative 3 to the negative 6 to get a positive 18 and bring down the 21. The reason this step is true and the route that I took to solve it is the distributive property. Next, that we don't have any more simplifying to do, let's undo the addition or subtraction first. In this case, we have the plus 18. We'll subtract 18 from both sides to keep it balanced, leaving us with negative 3x equals 3. That's true because of the subtraction property of equality. And the last step to get rid of this times negative 3 is we'll divide both sides by negative 3, leaving me with x equals negative 1. It's true because of the division property of equality. All right, the next example on the right has a new scenario for us. We've got a letter x, a variable, a term on both sides of the equation. And remember, I want my answer to look like this, to say x equals some value. Well, in that case, I need to start thinking to myself, how can I move one of the terms to the other side in order to get that, to get a variable only on one side of the equation? So I'm thinking to myself, how can I cancel this 2x from the right side? Well, if you have a 2x and you want it to go away, then you need to subtract 2x. Think about it. 2x minus 2x is 0. That meets my objective of getting rid of it from the right side. If you subtract 2x from one side, you have to subtract it from the other. And it's a good idea to go ahead and line it up with its like term. I can't take 2x from 5. I can take 2x from 3x because they are alike. 3x minus 2x leaves me with just x. Bring down the minus 5 equals 12. This particular step is true because of the subtraction property of equality. And the last step in this case, to get rid of this minus 5, we'll add 5 to both sides, leaving me with 17 as my answer because of the addition property of equality. All right, take a look at the example on the left. This is kind of a unique situation. There's really no simplifying that I can do, and this is one of those weird cases where I'm actually not going to get rid of the addition or subtraction first because my entire term here, the whole a minus 10 is all being, the whole left side of this equation is being divided by 10. I'm going to get rid of that part first, and the opposite of dividing by 10 is to multiply by 10. What's going to happen is the 10 on the top and the 10 on the bottom cancel each other out. That's the whole reason I chose to do that. So I'm going to bring down the a minus 10. If I multiply the left side by 10, I've got to be sure to multiply the right side by 10, which gives me 30. This step is true because of the multiplication property. And my final step would be to cancel or undo the minus 10 by adding 10 to both sides, giving me a final result of a equals 40, true because of the addition property of equality. The example on the right looks like we're going to need to distribute, and we have fractions now. That's okay, we can figure this out. Let's distribute the 1/2 to get 1/2 x. 1/2 of 6, or 1/2 times 6, gives you a positive 3. And now let's distribute on the right side. 2/3 times x is 2/3 x, and 2/3 times 9 gives me 18 over 3, or 18 divided by 3, which simplifies to 6. Now, this can be difficult to do in your head, and I recommend using a calculator, of course. We need to get the letters or the variables on the same side. So what I'm going to do is I need to cancel one of these from the other. This time I'm going to cancel the 1/2 x because it's smaller than 2/3 x. So I'm going to subtract 1/2 x from the left side so that my 1/2 x minus 1/2 x cancels each other out. I'm left with just 3. But I've got to remember to subtract 1/2 x from the right side. 2/3 minus 1/2 results in 1/6 x, and I'm going to bring down the plus 6. Now this looks very similar to one of the earlier problems we did, but by the way, this particular step is true because of the subtraction property of equality. And you may notice that I forgot to put the proof for the last step, or the first step that we did, and that was the distributive property that we did to simplify. Now to get rid of addition or subtraction, I'm going to get rid of this plus 6, and the reason being is because my goal is to get the variable by itself, so I'm working from the right side. Let's go ahead and subtract 6 from both sides to give me negative 3 equals 1/6 x. This is okay because of the subtraction property again. And the last step to get rid of the 1/6 is to multiply the right side by its reciprocal. It's okay as long as I multiply both sides, giving me a result of negative 18 equals x, and that's true because of the multiplication property. These two examples are what's called special cases. So let's take a look at the left. It says 3x minus 5 equals 3x plus 10. Well, my first thought here is to get the variables on the same side. So I'm going to cancel this 3x from the right by subtracting 3x. 3x minus 3x is 0. And then I'm going to subtract 3x from the other side. Well, if you notice, both of my variables canceled each other out. You're not finished yet. Look and see what's left. Does negative 5 equal 10? Since this is not a true equation, the answer here is no solution. Now keep that in mind as we go to the next problem. The next problem we need to simplify first a little bit. We'll distribute this negative 2 to both terms in that parentheses, giving me negative 2x plus 8 equals negative 2x plus 8. That's true because of the distributive property. I'm sorry, I forgot to put that on the last step. Negative 5 doesn't equal 10. We got to that step because of the subtraction property. All right, continuing on this problem. Now let's undo the negative 2x by adding 2x. Think about it. Negative 2x plus 2x gives you 0. That's my goal. I'm left with 8. If you add 2x to the left side, you got to add 2x to the right side. It also cancels, and you're left with an 8. Now in this case, 8 does equal 8. If you're left with a true statement, then the answer is infinite many solutions. It basically just means no matter what I plug in for x here, they're going to cancel each other out, and you're left with a true equation. Same thing can be said for my first example. No matter what I plug in for x over here, they're always going to cancel out, and you're going to be left with something that is not true. That's why there is no value for x that will ever make those situations true. All right, thanks for watching and hope this helps.